Slide 1 Intro Hook. Visual, stars zooming out, microscopic world zooming in. Speaker.
Tonight, we're diving into a place where reality itself stops making sense. A place so small that space, time, even physics break.
Welcome to the Planck length, the smallest possible distance in the universe.
Slide 2 Why this matters.
Visual, Planck length number appears, 1.6 times 10 superscript 3m. Speaker. Most people never hear about the Planck length.
But physicists consider it the boundary of reality. Go smaller than this, and spacetime stops behaving like anything we understand. Slide 3 Scale comparison. Visual, proton atom sand grain universe zoom out.
Speaker. If you magnify the Planck length to the size of a grain of sand,
then a proton becomes the size of the observable universe.
That's how insanely tiny we're talking. Slide 4 Starting the journey. Speaker.
Let's zoom down, step by step, from human height all the way to the limit of physics.
Slide 5 Human scale.
Visual, person standing next to height scale.
Speaker.
You're about 1.5 to 2 meters tall. Your eyes can see objects around 0.1 millimeter, about the width of a hair.
Slide 6 Microscope revolution. Visual, old microscope bacteria animation. Speaker.
In the 1600s, early microscopes revealed an invisible world, bacteria, cells, life hidden in plain sight.
Each discovery showed, there's always something smaller. Slide 7 Nanoscale. Visual, light wavelength bars 400 to 700 nanometers. Speaker. Visible light has limits. You can't see things smaller than its wavelength.
Electron microscopes pushed us deeper, down to 1 nanometer.
Slide 8 Atomic scale. Visual, atom diagram. Speaker. Atoms are around 1/10 of a nanometer.
If you lined up 10 billion atoms, you'd get 1 meter.
Slide 9 Nucleus scale. Visual, stadium comparison. Speaker. The nucleus is 10,000 times smaller than the atom.
Scale the atom to a football stadium, the nucleus is just a pea at the center.
Slide 10 Quark scale. Visual, quarks inside proton. Speaker. Inside protons and neutrons, we found quarks, possibly point-sized with no structure we can detect. Slide 11 The quantum problem. Visual, blurry particle cloud. Speaker.
At this scale, the universe stops behaving like tiny balls.
Particles become clouds of probability.
Heisenberg's uncertainty principle kicks in. The more precisely you know position, the less you know momentum.
Slide 12 High energy equals smaller scale. Visual, particle collider beam. Speaker. To probe smaller distances, we need higher energy. But high energy creates new particles, you change what you're trying to measure. Slide 13 Gravity enters. Visual, space fabric bending. Speaker. And energy also curves space. Pack too much in one spot, and you create a tiny black hole. Slide 14 The wall. Visual, black hole swallowing measurement. Speaker. There's a point where trying to measure something smaller causes a black hole bigger than the thing you're measuring. That point is the Planck length. Slide 15 The Planck length. Visual, big text, 1.616 times 10 superscript 3m. Speaker. At this distance, spacetime might not even be smooth.
It could be pixelated, made of tiny discrete units.
Like atoms of space. Slide 16 Where it comes from. Visual, C, G, H symbols merging. Speaker. When you combine three fundamental constants. Speed of light, c. Gravity constant, g. Planck's constant, h. The math gives you one unique length. The smallest meaningful unit of space. Slide 17 The other Planck units. Visual, icons for time, mass, energy. Speaker. Planck time, the shortest moment, 10 seconds. Planck mass, huge for quantum physics. Planck temperature unimaginably high. Slide 18, Why physics breaks. Visual, quantum mechanics versus general relativity. Speaker. Our two greatest theories, quantum mechanics and general relativity, both fail at the Planck scale. They contradict each other. The Planck length marks the battlefield where the next great theory must emerge, quantum gravity. Slide 19, Quantum foam. Visual, chaotic spacetime grid. Speaker. At these tiny scales, spacetime becomes like foam, bubbling with tiny black holes and wormholes appearing and disappearing. Slide 20, The mystery. Visual, question mark over space grid. Speaker. We don't yet know what really happens below the Planck length. It may be the universe's smallest pixel. Or something stranger than we can imagine. Slide 21, Outro. Speaker. The Planck length isn't just small, it's the boundary of reality as we know it. Below it lies the next revolution in physics. Visual, like plus subscribe animation.